Welcome to the third episode of the Sci-Fi Show. Here we talk about science and philosophy with two gentlemen who have been described as boss-level atheists. Alex Malpass being one of them. How you doing, Alex?
I'm good, thank you very much. Does that make me the Bowser of atheism? Or
I think that's right. Yeah. And we've got Dan Linford. How are you doing, Dan?
I'm doing well, thank you.
Good, good. So today I experienced the dark side of religion. Maybe, part of the motivation for doing a show like this, because I went to my parents for afternoon tea and it's Passover. And so they can't cook the normal things. So no apple and blackberry pie, no amazing chocolate cake, not even bagels. And they asked us, why are you going against religion? So that's why. Anyway, last time on the show, we looked at the moral argument for God's existence. Many philosophers consider it the worst argument for God. It's pretty bad. In contrast, cosmological arguments are often considered, well, they were voted the best argument for God. And the Kalam is probably the most well-known version of the argument. So we're going to reveal a new challenge today to the Kalam that you might not be familiar with. It hasn't been covered in the previous videos that I've made on the argument. We'll put a link to those. But first, Alex, tell us, what is the Kalam argument and why are we so fascinated with it?
well, so it's a very simple syllogistic argument. It just premise one says everything that begins to exist has a cause. Premise two says the universe began to exist, and the conclusion is that the universe had a cause for its existence. That's sometimes called stage one of the Kalam, and then sometimes stage two will be trying to establish that the first cause, that's the thing concluded in the conclusion of the step one, that first cause is a kind of personal creator of the universe who's timeless and spaceless and blah, 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 and cares about what you eat on a Sunday or whatever. So that's, and it's in a family of cosmological arguments, as you said. It's super interesting in some ways, not necessarily because from our point of view, we find the conclusion super difficult to avoid, and maybe it makes us believe in Christianity or something. But it seems, from my point of view anyway, it's super interesting because it's an intersection of lots of things that are independently interesting, like philosophy of religion, but also things about infinity and beginning of time, cosmogony, and stuff like that. So it's a great argument for it being a kind of fertile ideas playground in which lots of different things come together, and it's a fruitful place to sort of play around and see what you can come up with. So yeah, it is fascinating, definitely.
Yeah, I think even if you don't believe in the conclusion, whether the universe had a beginning or not, whether infinity is allowed or not, what's the nature of causation? I mean, these are just fascinating topics. And we should say this is how we all met, because I made films on the Kalam and got in touch with Alex and Dan. So this is how we all kind of know each other.
Mm-hmm.
And I have made several films on competing models of the Big Bang. And many of them have like a sort of hourglass structure. So we see a contracting region, a quantum throat in the middle, then an expanding classical region. Some of these have a reversal of the arrow of time, some of them don't. And you find this hourglass in some interpretations of the Hartle Hawking model. You find it in Loop Quantum Cosmology and some string cosmologies. You see it in versions of eternal inflation, like the Carroll Chen model. You see it in Julian Barber's Janus Universe. Neil Turok has a model with it. So it's really, really common. And I think it has some plausibility. But Dan, what have Kalam advocates said about this kind of universe?
Kalam argument proponents want to be able to use astrophysical cosmology to argue that the universe had a beginning. So they like the Big Bang theory for that reason. But if one of these hourglass cosmologies is true, then the Big Bang wasn't the beginning. So if the cosmos really did contract and then re-expand, the Big Bang was not the beginning of the universe. If we knew that some hourglass cosmology is correct, then physical cosmology wouldn't support the view that the universe began to exist. Now, Kalam proponents have two choices here. One choice is to argue that the cosmos probably isn't shaped like an hourglass. But a more popular choice is to argue that we've misinterpreted these hourglass models. For example, William Lane Craig and James Sinclair argue that the contracting portion isn't really to the past of our universe. Instead of one universe contracting to some minimum size and then expanding into a new universe, they say that there are two universes expanding from a common origin. So we have a choice in how to interpret hourglass cosmologies. We can either interpret hourglass cosmologies as a big bounce or as a big bang. And for Craig and Sinclair, we should interpret hourglass cosmologies as involving a double bang.
Right. So actually, just before we get on to your paper and some really exciting dilemmas and ideas, I just want to check, this would apply really only to those versions of the hourglass that have a reversal of the arrow of time. So time sort of points both ways away, because some of them don't have that. So when we're talking about this sort of dilemma, we're talking about those versions of the hourglass,
That's
right?
right. So I have another paper called Big Bounce or Double Bang, and in that paper, what I argue is that you can't interpret all of these models as ones in which two universes originate from a common origin, because the reason why they think that you can do that is because you have this reversal of the thermodynamic arrow of time, and we'll get into more of what that reversal involves and what the thermodynamic arrow of time is. But yeah, certainly on models that don't have that, on hourglass cosmologies that don't have that feature, you wouldn't be able to give that kind of interpretation.
Right, right. But for those that do, so you've presented to the Kalam advocates this thing, we call it the interface dilemma. I think this is absolutely fascinating. It's not well known in Kalam circles, and it should be. So Dan, explain, what is this interface dilemma?
Yeah, sure. So time has a direction. We've all seen eggs fry, but we've never seen eggs unfry. Likewise, we have memories of the past, but we don't have memories of the future. We can say that time has a direction. One of those directions we call the past, and the other we call the future. So here's the interface dilemma. There are two possibilities. On one hand, the direction of time might have a further physical explanation. In that case, we say that the direction of time is reducible. And in that case, we have good reason to deny the principle that anything that begins to exist requires a cause. On the other hand, the direction of time might not have a further explanation. And in that case, we say that the direction of time is not reducible. But then we do have good reason, but then in that case, we do not have a good reason to accept Craig and Sinclair's interpretation of hourglass cosmologies.
Mhm.
Alex, any thoughts? You read the paper. Did you have any thoughts when you read it?
Yeah, well, quite a few. I think we should unpack each horn of the dilemma,
Yeah.
I guess. So maybe if we start with the first one. So on the two horns, the first one says that time is reducible to something, and the second one basically says it's not the case that time is reducible to something. So if we go through them one by one, on the first one, let's assume that time is reducible to something. I guess first of all, we'll need you to explain what the kind of plausible looking accounts of what time would be like if it was reducible to something are, and how would
Yeah.
that
Can I just
undermine causation?
just interrupt for 1 second? When we say time is reducible, let's clarify. Are we saying that it's an emergent phenomena? So it's not there at the fundamental nature of reality. It's something emergent. Is that
Pretty
right,
much,
Dan?
yeah.
So it
Yeah.
depends upon what we mean by emergent. I mean, that word gets used in different ways in different literatures. In the philosophical literature, emergent often means that you have some radically new set of phenomena that occur on one scale that are not entailed by what occurs at a lower level scale. In the physical sciences, though, when we say that something is emergent, we just mean that some phenomenon that occurs at some level has a complete explanation in terms of something that occurs at some lower level. And so they kind of are opposed notions, right? So emergence as it's used in the physical sciences refers to this idea that there's something radically new, but ultimately has an explanation of something at a lower level. Emergence in some parts of philosophy means that you get something radically new without an explanation at a lower level. If we go with the emergence in the sense that it's used in the physical sciences, then causation, and to say that causation is reducible is to say that it's emergent in that sense.
Right. And so what's the big worry for the Kalam advocate if time is reducible then? Why should they care?
Yeah, so suppose the direction of time is reducible. How could it be that the direction of time has a further physical explanation? What would that explanation look like? Well, to simplify matters, let's suppose that the fundamental laws were Newton's laws, and that a world consisted of a collection of hard particles that could impact and then rebound off of each other. We know that our world isn't like that, but just to make the explanation easier to understand, suppose that it were. Newton's laws are symmetric with respect to time. In other words, as far as Newton's laws are concerned, nothing at all picks out one direction as the future and the other direction as the past. So for example, If we watch a movie of two of these particles colliding and then rebounding off of each other, no one would be able to tell whether we ran the movie forward or in reverse. So even though the fundamental laws do not recognize an asymmetry between the two directions of time, nonetheless, we do recognize a distinction in our ordinary experience. So how can we reconcile those two things? How can we put it together that at this fundamental level, there's no direction of time, but in ordinary experience, there is a direction of time? Well, the microphysical state of a system specifies exactly what all of the parts of that system are doing. So it's a description that specifies the positions and momenta of all of the particles composing the system. In contrast, the macrophysical state specifies the features that are ordinarily available to us. For example, the macrophysical state of a gas might specify the pressure, volume, and temperature of the gas. Any given macrophysical state corresponds to a very large number of microphysical states. So now imagine that there's a space where each point represents a specific microphysical state. Let's call that space configuration space. Since there are many microphysical states consistent with a given macrophysical state, the macrophysical state corresponds to an entire region of configuration space. The size of that region is roughly what we call the entropy. So suppose that a system is in a very special macrophysical state for which there are very few microphysical states, so that the system has very low entropy. In that case, given the laws of physics, the system is very likely to evolve into a region corresponding to a very large number of microphysical states, and so to evolve into a state with higher entropy. So given that a system is presently in a very special state, and given the laws of physics, the system will tend to evolve into a state that is much less special. That's why, for example, if you start a gas in a corner of a room, the gas will expand to fill the room. Or if you place an unfried egg into a hot frying pan, the egg is very likely to begin frying. So that gives us part of the story as to how we can have a direction of time in our ordinary experience without any time asymmetry in the fundamental laws. But that cannot be the whole story, and here's why. If a system is presently in a very special state, then the system is most likely to have come from a less special state. That is, if what I've said so far were the whole story, and the system is now at low entropy, then the system is most likely to have come from higher entropy. So contrary to our experience, if the egg is not currently fried, then the egg is most likely to have come from a state where the egg was fried. Well, so what we need is a regress of ever more special states into the past, until we come to the most special state that there could have ever been. In philosophy of physics, this is an absolutely bog-standard way of explaining the asymmetry of time. The most sophisticated and well-developed version of this view is called the Metaculus. In turn, the Metaculus is a conjunction of three propositions. So first was called the past hypothesis. That is, that at some time in the past, the universe was in a very special state, where the universe's entropy was the lowest that the entropy has ever been. Second, the fundamental dynamical laws, whatever they turn out to be. In our example, we imagined that the fundamental dynamical laws were Newton's laws. Now we know that the fundamental laws aren't really Newtonian, and we probably do not yet have the fundamental laws. So the second proposition is really a placeholder for whatever the fundamental laws turn out to be. And third, there's the statistical postulate. That is, a uniform probability distribution over the portion of configuration space consistent with all the information we have about the world. According to philosophers who endorse the Metaculus, all of the objective probabilities that appear in science are conditionalized on the Metaculus. For that reason, the Metaculus is said to provide a probability map of the world. The Metaculus provides an all-encompassing story of how it is that all of the other sciences are related to physics. Now here's the upshot for the interface dilemma. If the direction of time is reducible, that is, if the Metaculus is correct, then the asymmetry of causal influence, so the distinction between causes and their effects, is also reducible and has an explanation in terms of the Metaculus. If causation is a specific physical phenomenon with an explanation in terms of yet more fundamental physical phenomena, then it's false that there must be a cause for anything to begin to exist. So that's the first arm of the interface dilemma. If the direction of time is reducible, then most likely the causal principle needed for the Kalam argument is false.
Right.
Okay, I
So
think we need to go over some of that again, just because I think that for the listener, it will be helpful to spell some of that out. A lot of ideas were covered quite quickly there. So are we all right to just maybe reiterate some of those key
Yeah,
ideas? I mean, first of all, can we just say something about the name? Like, where does the name comes from? David Albert, right? It's a weird name, though, isn't
sort
it?
of.
wasn't it a Coen
So
Brothers movie?
that's right. There's a Coen Brothers movie called The Serious Man, and it's a film about it's about a bunch of things, but the main character is a physicist, and his brother is a very mentally troubled individual who spends a lot of his time in the film scribbling in this notepad. At one point, he gets asked, like, "What is this thing that you're writing in?" And he says, "Oh, this is the Mentaculus. It's a probability map of the world." Um, and so David Albert and Barry Lower, who are big Coen Brothers fans, took their name from that film. Even though in the film it's kind of the scribblings of a troubled individual, both Albert and Lower mean this quite seriously. They take this hypothesis of the Metaculus very seriously. It's a kind of codification, a kind of more sophisticated version of a view that's been around in physics for a very long time. It goes back to folks like Boltzmann in the 19th century, um, and it also appears in there's this set of lectures that Feynman gave called "The Nature of Physical Law," and in there's a chapter on the past hypothesis. Um, but yeah, that's the origin. It's from the Coen Brothers movie.
Would you say the bottom line here is that when we think about how this arrow of time emerges and we take the Mentaculus into account, what we're really saying is that causality then is not a fundamental feature of reality. So that bit of the Kalam that says if the universe has a beginning, it must have a cause, that's just wrong, or at least it's unjustified. Is that fair?
Yeah. So on the Metaculus view, there's a whole bunch of different kinds of philosophically important asymmetries that turn out they're going to have an explanation in terms of the Mentaculus. So there's the asymmetry of our memory, the fact that we remember the past but not the future. There's the asymmetry of epistemic access, that our epistemic access to the past is very different than our epistemic access to the future. There's the asymmetry. There's the so-called asymmetry of manipulation. There's certain kinds of manipulations we can perform on the world and we can't perform others. And in this case, we're talking about the asymmetry of causal influence. So that's the asymmetry that distinguishes causes from effects. And the claim made by Metaculus proponents is that that asymmetry, just like all these others, is going to have a reductive explanation in terms of the Metaculus.
And that comes with basically saying that this hourglass universe has this middle point that is the beginning. So in that
Yeah.
that leads to that, and then we say if in that scenario, no causation.
So the Mentaculus is independent of these cosmological models, but often what people do when they present these cosmological models is that they place the location for that past hypothesis, that low entropy condition. They place that at the throat of the hourglass, or what I've called the interface. That's the interface of the interface dilemma. Is that point where the contraction ends and the expansion starts? That in between place the throat of the hourglass. That's the interface. That's also where people claim this low entropy condition is supposed to obtain. So if you think that the direction of time has this kind of reductive explanation, and you also buy into a cosmological model, where the thermodynamic arrow, so that's the arrow describing the entropy gradient. If that points away from that throat, then it becomes attractive to see that throat as the birth of, in some sense, of two universes. But
So hang on, I've got an hourglass here. Is it
yeah,
focusing? Yeah. So we're talking about this is the middle, and the arrow time are pointing up here and down there in this sort of scenario, right?
that's right. Yeah. So if that's the right interpretation of hourglass cosmology, is that interface is a beginning. Well, it seems like the only way that you're going to reach that conclusion is if you think that there's some correspondence between the direction of time and these physical parameters like the entropy. But then the only good reason that I can see that you would think that there is such a relationship is if you think the direction of time has this reductive explanation in terms of something like the Metaculus.
Right. Okay, so I guess the alternative is to say that the middle is not the beginning. Now, I know like Sean Carroll has argued, quite forcefully when he debated William Craig, it's not the beginning. And maybe you might write off Sean as an atheist who wants that to be true. But actually, I want to give a quote here from Don Page, who is a former student of Stephen Hawking, and is an evangelical Christian. And he said to Bill Craig after the debate with Sean Carroll, and I open quote, "It is erroneous to say that the bounce is a true beginning of time, since the structure of space-time there has time-like curves going from proper time of minus infinity through the bounce and then to proper time of plus infinity. That is, there are world lines that go through the bounce and have no beginning there. So it seems rather artificial to say that the universe began at the bounce. That is in the middle, just because it happens to be where the entropy is minimized." I think Sean made that point very well in the debate, close quote. And I should also add, when I interviewed Alan Guth, who's the father of inflationary cosmology, he likes these models. He said, "I often call the middle the logical beginning, in the sense that's where we begin our description. If somebody wants to leave off the word logical, I would add it back in." So, so that's, I guess, the other horn of the dilemma. Is that right?
Yeah, that's right. So on the other horn, the one where the direction of time does not have a reductive explanation in terms of something like the Metaculus, or indeed any other kind of reductive explanation, then there's no reason to think that any particular physical process would correspond to the direction of time. So Craig sometimes talks about having this kinds of like God's eye perspective, where God could see periods of the universe's history where the entropy decreases before it increases once more. And from that kind of perspective, the entropy gradient might be in some sense pointing the wrong way, or the way that we don't intuitively think that it would point. But from the perspective of metaphysical time, there's no reason to think that those two things have to go together. So on the other horn of the dilemma, the one where we have these two things coming apart, there's sort of two different interpretations of hourglass cosmologies that one could give. One interpretation is where both the universes are the simultaneous cause of one another. In that case, the universe is a closed system of causes. There's no need to invoke a supernatural cause to get the whole thing rolling. On the other hand, you could just have an interpretation that is sort of naturally suggested by what Craig has otherwise said, which is that the universe on one side of the throat causes the universe on the other side.
It's funny because they often invoke God as a sort of, well, how could God cause the universe if he's, doesn't have a prior time? Well, aren't causes supposed to be prior? And he's like, no, God causes can be simultaneous. So basically, you're kind of using that weapon against him, right?
That's right. Yeah. So it's really important for Craig's view that when God creates the universe, God is acting simultaneous to the birth of the universe. But if we have a model on which you have two universes that are sprouting out of one interface, that are connected to one another. So, for instance, on a model where one of the universes precedes the other, one way you can describe what's going on is that if you can follow trajectories from one universe into the other one. Now, those same trajectories are there if you take this other interpretation on which both universes begin from the same origin. It's just that the trajectories are sort of U-shaped, right? So you would, instead of seeing it as one trajectory that goes off one universe into another, you would see maybe two trajectories that begin from a common origin. But nonetheless, the two are connected together. And so it gets worse for Craig in some sense, because so when you ask Craig about whether there are such things as instants or points of time, so infinitely small increments of time, Craig says, no, there's nothing like that. What there are instead is that there are intervals of time that you can break down into ever smaller portions. So there's the present day, which can be broken down to the present hour, which we're talking the present minute, present second, and so on. There's no infinitely small gradation that you can break down into. Now, that view is really important for Craig because he wants it to be the case that there are no actually infinite collections. If there were actually infinite increments of time within any finite interval of time, then that would be already an actually infinite collection on his view. So he has this view on which time is said to be sort of gunky. In other words, there's no smallest increment that you break it down into. You can just always break it down further. On a view like that, there's no instant that corresponds to the interface. Instead, there's just all the regions of time, or all the intervals of time, rather, that include the interface. So there's this interval of time of indeterminate description that includes the interface that connects the two universes together. And it's unclear why we couldn't just say that the two universes inside of that interval are the simultaneous causes of one another.
Alex, any thoughts?
Well, I really liked the way that Dan was weaving together lots of the kind of herd of cats that is Craig's various different views and how often they don't gel together very well. So, like, as you point out, then Craig has this quote, which is about like the extent of the present, and it's him saying, okay, there's no like smallest moment, the thing that's present on presentism. It's him saying, well, the present day, we can talk about the present day, the present moment, the present year, but there's no non-arbitrary duration of that interval of the thing that's present. He just thinks there's lots of different ways of cutting it up, which is really quite strange because you do think it's like, I mean, unless you're like a complete hardcore kind of B theorist and eternalist, you want to say that there's some like ontological distinction between where the things that are existing in the current year and the bit that in past or the future of me, do those things actually exist or not? It can't be an arbitrary choice about like some, value I select in my theory or something. There has to be some real meaning behind that about which one is real and which one isn't. I mean, that's what a presentist wants to say. And Craig's a presentist, but for some reason he
Alex,
this weird view about that.
Explain to the audience, what is presentism? Because not everyone is going to be...
Okay, so presentism is a term in the kind of ontology of time. So like what time is, and the idea is basically just that the present moment exists. Present moment is the only thing that exists, and the past and the future are domains of things that don't exist, right? So it's kind of familiar to your phenomenological experience, where though you can have memories of yesterday, the memories that you're having of yesterday are present right now. They are and tokens of things that are present. In fact, everything you're kind of actively interfacing with are present. You can't interact directly with things that are not present. And the thought would just be, the simplest explanation of that is that they just don't exist. The present moment is just the kind of knife's edge of being, and it's sort of moving or something. These metaphors really don't sustain much pressure, but there's some kind of supposedly intuitive idea about like the present moment being the only thing that exists. And then the contrast to that would be eternalism, right, which is just the contrary. So we're saying not just the present exists, right? Other moments, ones that from our perspective are past or future, they're just the same as the present in terms of ontology. They exist in the same way that the present does. So it's a straightforward distinction. Does just the present exist? That's presentism. Or does more than just the present exist? That's eternalism. Just really quickly, it's worth noting that that's not the same distinction as the A theory and the B theory, although common. We were complaining last week about apologists not knowing anything about meta-ethics, but often they don't know anything about the philosophy of time either. And they could continually run together these two distinctions, right? So people will tell you that, on the B theory, and then they'll just tell you something that sounds like they're describing eternalism, right? The A theory, B theory thing is not about the ontology of time in the same way that I was talking just then. It's more about like, what's the fundamental kind of relationship between events. Even my saying it that way around sort of tilts it in favor of the B theory. The B theory is basically saying you've always got pairs of events, and they're related to each other in a kind of before and after relation, earlier than, later than. So fundamentally, it's a two-place relation. Right? The A theory is basically saying fundamentally it's a one-place relation. It's just a property. So an individual moment is just present. or it's past, or it's future. And it's not like a relative thing. It has those properties sort of absolutely. So I don't want to belabor the point because it's a bit of a tangent, but it's a little pet hobby horse of mine to distinguish those when people run them together so often. A theory, B theory, presentist, eternalist things, not quite the same distinction.
Could you give maybe like an everyday example, like the B theory, like, and the A theory, presentism? Like, let's go to the shops. How does time unfold in the different sort of versions?
Yeah, okay, so I go to the shop and then, like, to begin with, I'm in, I don't know, the like baking aisle or whatever, and I'm picking up some like flour for my cake, and then I go to the alcohol aisle and I'm choosing a bottle of wine to go with it, right?
Well, not on Passover. There's no flour.
Well, I can buy both of those from Passover actually, but as a heathen and an atheist, as long as I sacrifice enough babies on my way into the store, I'm getting credit. But no, the point is that, you know, taking those two events, right, on the A theory, it might be that, like, it's now true that I'm buying the flour, and it will be true that I'm buying the wine, right? And it was true that I sort of walked into the shop or something. The B theorists, I mean, they both agree about the same facts. It's just the way of talking about them. What they're saying is fundamental. And the B theorist is going to say something like, well, what you've got is the flour buying event is earlier than the wine buying event. The wine buying event is later than the flour buying event. So that, and what's sort of notable about that, the sort of weird thing about it, is it's not just two ways of describing the same thing, is that the A theory properties change, right? So, like, I'm buying flour, and then you just wait, and, like, I'm not buying flour anymore. Now something else is happening. And that's just this peculiar thing about first-person experience of time, is it just like happens, rolls over you, kind of without you having to do anything. On the B theory, no, just as familiar and useful way of talking about things, I think this thing happened before that thing or whatever. Those truths, those facts are the same over time. They don't change. So, like, if it's true that my buying the flour is earlier than my buying the wine, then there's no perspective on which that's different. It's not like after that happens, they switch and the flour buying is after the wine buying or something. Their relationship to each other is timeless. Right, so it's an unchanging fact. So even though we're describing the same fact, I use kind of vocabulary that presupposes a perspective upon which the temporal properties change in the A theory. And in the B theory, I describe the very same facts, the same things. It's just that the facts that I'm describing are not facts which change over time. They're facts which stay fixed. So right, that's kind of, I think, why people conflate the two things together.
And then what does this all matter for the Kalam? Because Kalam advocates tend to be this presentist. Why does that matter for the Kalam argument? I mean, like, who cares? Like, what's the difference?
Well, I'll briefly say one or two things and hand over to Dan. But but Craig's very explicit that the Kalam in his when he's wielding it presupposes the A theory. So he literally says, quotes something to that effect exactly. So he's saying, I think possibly it's more to do with the premise 2 stuff about whether the past had a beginning, but maybe it's also to do with premise 1. But the idea is that, like, there's this kind of like temporal passage being real, and it's not just a way of talking or something that goes on in your head, but it's a real thing in the actual world that's taking place. And if that wasn't there, then some of the arguments he relies on in order to prove the second premise get undermined, or so he says, right? On the other hand, I think that, and Dan's probably going to say more about this, but on the view we've talked about, the Metaculus view, where time is a reducible concept to some underlying notion like entropy or causation or something. When we look at the microphysical laws, that they're the same backwards and forwards, as Dan's pointing out. Like, well, I suppose you gave the example of it works on Newtonian physics, but the microphysical laws are time asymmetric, time symmetric as well. But what that means, I think, is that neither the A theory nor the B theory would be an appropriate way of characterizing time when we start thinking about what those physical structures are telling us. Rather, we'd have to have something like a C theory, which a friend of mine, Matt Farr, has done quite a lot of work promoting in the last like 10 years or so. But then on that theory, instead of it being a one-place relation on the A theory or a two-place relation on the B theory, the C theory has that it's a three-place relation. So you're saying, you've got three things, A, B, and C, right? A and C contain B. B is in between A and C. And that's an even more structured and detailed description. But on that view, it sort of gets you all the facts that you need to say in order to state those microphysical laws and all of the states and stuff that go along with them. But you're not bringing in that there even is any asymmetry at all in either direction, which is quite interesting as well. Anyway, I'll shut up and let Dan explain more detail.
So,
yeah. Dan,
yeah,
just
I
jump
mean,
back for us, like presentism on the Kalam, and also what does it mean for the interface dilemma that we've just presented?
right. Well, one of the things that comes to mind from the distinctions that Alex just laid out. So yeah, I think he did a good job going over the A, B, and C theories, right? That the Metaculus requires something like a C theory. That on that view, you get B relations, but the B relations are reducible, right? So you get before and after relations, but they have a further explanation in terms of Metaculus. It's more fundamental than what people call the C series. That is, more fundamental than the B series. That is the sequence of events ordered in terms of before and after. Is the C series, which is ordered in terms of betweenness relations. There's a further view called the D theory, which is a view according to which you don't even have these betweenness relations. Those are also reducible. When I had my debate with Andrew Loke, I pointed out that there's this view in philosophy of physics according to which A, B, and C theory are reducible. He wanted to say that time exists anyway because somehow you still get change. I have no idea what he was talking about, because if all you have is a D series, if you don't even have a C series, I don't know what change is supposed to amount to. But in any case, in terms of the Kalam argument, one of the reasons why Craig wants to pursue presentism is because he defines beginning to exist in terms of a tensed theory of time, in terms of something like an A theory of time. So for Craig, on Craig's view, if the A theory was false, then nothing, including the universe, would ever begin to exist. Now, that's not my view about what beginning to exist means, and many people have a different view about what beginning to exist means. But on Craig's own view about what beginning to exist means, if A theory weren't false, then the Kalam argument doesn't get off the ground because nothing at all begins to exist. And as far as the causal principle goes, if nothing began to exist, well, then nothing would require a cause for its beginning to exist either. In terms of the interface dilemma, so remember, on one arm, we have the view that time is reducible, and on that arm, we have the view that the most likely causation is going to turn out to be reducible. On the other hand, we have the view that the direction of time is not reducible. It has no further physical explanation. Maybe time is something that somehow transcends the physical world. Craig sometimes talks like that. He talks about God's absolute time or God's metaphysical time that's supposed to be beyond the physical world. And on that side of the dilemma, it becomes very difficult to see why we should interpret the entry minimum as a beginning at all. So
right. I'm just
yeah.
wondering, Dan, is there a way that the calm advocate could have their cake and eat it? Could they concede, all right, we concede time is reducible, but we're going to hold on to causality as still being fundamental? Could they try something like that?
Right, so it's possible the Metaculus is correct even if causation is not reducible, right? So it's possible that, for example, even though a bunch of other asymmetries need a reductive explanation, the asymmetry of causal influence doesn't, for whatever reason. But I don't think that possibility should strike us as very likely. Why should it be that causation has no further explanation when all of these other asymmetries do have a further explanation? Sometimes what's claimed is that causes and effects don't need to be related in the way that time is related. So, in other words, causes, for example, don't have to precede their effects in time. Maybe that might be a way around the Metaculus. But we don't find causal relations like that in the world when we examine it. However you feel about the metaphysics of time, your metaphysics of time should be consistent with our physics of time. That doesn't mean that we need to take our physics of time. Sorry, it doesn't mean we need to take our metaphysics of time from our physics. that your metaphysics shouldn't contradict, our experimental findings or the empirical adequacy of our best physics. And one of the things that we know about our best physics is that you can't have instantaneous signaling between two different events, and that's because nothing can travel faster than the speed of light. The only way that something could instantaneously signal another thing, at least insofar as we understand physics, is if they were located at one and the same point in space-time. But barring that possibility, barring the possibility that causes and effects are located at exactly the same point, causes do always precede their effects. And we do have these kinds of asymmetric relationships that we need to explain. By the way, the other thing that needs to be brought out here is that even if you rejected the view that the direction of time is reducible, you're still going to need to explain why it is that physical processes happen in one direction as opposed to another. So if you have like becoming around, if you have this metaphysical idea about the passage of time and so on, how is it supposed to be that the passage of time latches onto the physical constituents of our world in the right sort of way, that somehow processes happen only in one direction but not in the other? Or what is the interaction that happens between the becoming of time on one hand and physical stuff on the other that forces it to do one thing as opposed to the other? And it seems like the explanation you're going to end up giving there looks an awful lot like the Metaculus anyway. Unless you want to invent some wholly unprecedented influence that temporal becoming is supposed to have over physical processes.
Right. So to sum up then, basically, the difficulty is, okay, we've got these, things that unfold in time, and they're suggesting there's this uber metaphysical time. And it's like, well, how do they coincide, with like psychological arrow of time, entropy increase, things like that. Yeah. But Alex, I want to ask you a question here. Oh, go on. Sorry, Dan.
Craig sometimes claims that the two are connected by a law of nature, so that there's somehow, they didn't have to be connected, but there's a law of nature that connects the two. Well, if that's the right thing for him to say, then we should never see exceptions to, for example, the second law of thermodynamics, right? So this idea that the entropy for a closed system increases over time. But in fact, the second law of thermodynamics is well known to be a purely statistical phenomenon. It's what systems tend to do when you have very large numbers of parts. But if you look at, for instance, a pollen grain under a microscope, you'll see something called Brownian motion, where pollen grains tend to sort of do this jittering motion. That's because they're being bombarded on all sides by atoms, and those atoms will sometimes bombard more on one side than on another. That jittering motion is itself a kind of microscopic effective violation of the second law of thermodynamics. And if you keep track of, say, the entropy of a closed system for very long periods of time, you'll see that the entropy will fluctuate up and down. And the probability for a large fluctuation is very small, but if you wait long enough, you'll eventually see a fluctuation of any size you could possibly imagine. So it can't be a law of nature that connects the two, nor can it be some sort of metaphysical or logical necessity, because Craig has argued that God could watch as entropy of the whole universe decreases before increasing again. So it doesn't seem like whatever the connection is supposed to be, it can't be a law of nature, it can't be a matter of metaphysical necessity, and it can't be a matter of logical necessity.
So Alex, what I want to ask you is, so if we're suggesting, okay, time is reducible and we're going to lose the causal principle as some fundamental principle, it might still be there at the sort of macroscopic level of the universe. In our day-to-day lives, causality may rule, but it might not be there fundamentally. Why don't raging tigers spontaneously pop into existence?
If only I had a modus tollens to help me explain this. It seems to me the right thing to say about that is, I think first of all, the question is always sounds like it's posed under the assumption of something quite confused. I think there's something something's gone wrong before we have got to the point where we start wondering why Beethoven and bananas or whatever it is don't just pop up randomly in the room in front of me. But like, I think, just put it into perspective, the idea is supposed to be that like the causal principle, right, which is basically just premise one of the Kalam, right, nothing begins to exist without a cause, right? If that was violated, then anything could just pop out of existence without a cause at any point. So it has to be a universal law all the time and forever. Otherwise, we'd expect to see things popping in to existence all the time. That's the idea. And there's a bit from of Oppie somewhere where he interacts with this question and says something that sounds completely right to me, which is that like when we're in the middle of the cut and thrust of a kind of universe where there's causal chains and things occupying bits of space and fields energized to different degrees or whatever, it's not really like there's room there waiting for instance, pianos to just appear. I mean, if a piano did appear, it would displace a bunch of stuff that was already there. And plausibly, you could think of the universe as being kind of full, right? In a sense where like you can't just inject new stuff into it. I mean, I do say this wondering whether or not I'm violating some principles that people in physics sort of just think of as pedestrian and normal. I mean, space expands, doesn't it? There's new space that wasn't there in the first place. So maybe this is a violation of this principle I'm appealing to here. But it seems to me that like once your universe has got going or whatever, once there's a kind of bounded region of space and time with stuff going on inside it, the very presence of those things is what keeps out new things from just appearing inside them. For all I know, outside the universe, there are pianos and Beethoven and whatever just popping into existence, right? Maybe that's true. They're just not popping into existence and displacing other things that currently exist, like in front of me. Even though it doesn't seem like there's anything directly in front of me, of course there is. There's loads of fields, there's loads of particles, there's loads of stuff happening. And that seems to me just enough to brush away this worry that maybe pianos might be popping into existence. I mean, I just think that like they might be popping into existence in a way that couldn't possibly causally interact with us, in the sense outside the universe altogether. And how could I forbid or say anything about that? I think the mere presence of stuff in front of me in the universe, that however thin it might seem, is enough to prevent stuff popping into existence from nothing, right? Does that seem bonkers to you guys, or does that seem reasonable?
I mean, indeed, like the conservation of energy, as far as I understand, Dan, you can correct me if I get this wrong, but it's derived from symmetry principles that are actually violated in an expanding universe. So, so you get conservation of energy locally, where the expansion of the universe is irrelevant. So at distance of like a couple of million light years or something, but as you go further out, then you can't really even define necessarily conservation of energy. But the thing that I always think about is, and I think Carroll mentioned this in the debate with Craig, but I'm not sure. It's been a while since I watched it. But he said something like, well, we expect causality where we have a universe operating with an entropy gradient. We have an hour of time. Okay, so we have causality. But you could be somewhere where if that disappears, then causality wouldn't be real. And another possibility, and I think Vilenkin would probably endorse something like this, is that you could get a tiger appearing in your room, but the probability is just really, really low. So the fact, that you don't see a tiger appearing in your room doesn't tell you that it couldn't. It just tells you that it's unimaginably unlikely.
So one thing that I think is really important to bring out here, and this actually I think interacts with what you were saying about Vilenkin. So sometimes the reason why people make an objection to the causal principle from physics, and I think part of what people sometimes have in mind when they bring up this question about why raging tigers don't spontaneously appear, is because some people have interpreted quantum mechanics to say that our universe is fundamentally indeterministic. Now, as it turns out, there are many different interpretations of quantum mechanics, like the many worlds interpretation or Bohmian mechanics, various other things, according to which there is no quantum indeterminacy, according to which our world is fully deterministic. Now, you couldn't predict the outcome of an experiment, that much is still true, but nonetheless, despite the fact that you can't predict the outcome of any experiment, the way that the universe evolves is fully determined from um, from its past conditions. Or actually, it turns out, since the laws of physics are symmetric with respect to time, also by its future conditions. Now, what's really important here is that the kind of reduction of causation that the Metaculus gives you is not one according to which, in the reductive base of causation, that is, in the things that explain causation, that those are indeterministic, or that things happen for no reason or something like that. No, there's things still happen for reasons down there. It's all stuff that can be wrapped up under the laws of physics, right? I mean, we gave the example of how, or I gave the example of how Newtonian physics has this feature. People, friends of the Metaculus, would claim that it also doesn't have causation built in there, and yet Newtonian physics, even though it's fully deterministic, sorry, I said that a bit odd. So even though Newtonian physics doesn't have causation at this fundamental level, it still is fully deterministic. I think, though, that there's another issue to be brought up here. It's an issue about the laws of nature. So here's 3 different accounts of the laws of nature. So there's one account that tends to be favored by friends of the Metaculus, but despite what is sometimes said, is actually independent of the Metaculus. It's this account that some people attribute to David Hume, is also attributed to David Lewis. It's an account according to which all that really exists is space-time and then a distribution of properties over space-time. And then everything else is supposed to be explainable in terms of that distribution of properties and how that distribution of properties might covary between the actual world and other possible worlds. So on that view, a law of nature is just it's a really good summary of that distribution of properties. But here's another account of the laws of nature. It's an account that's due to Dresky, Tooley, and Armstrong. According to this account, a law of nature is a brute necessity between 2 properties. So you have 2 properties linked by this brute necessity, and so they always have to come in together, in other words. And that's what a law of nature is according to the DTA account, according to the Dresky, Tooley, Armstrong account. Now there's a third account that you might associate with someone like Aristotle, called the essentialist account. According to the essentialist account, the reason why things obey laws of nature is because of what they are in virtue of their essence or nature. So if they were doing something else, then they just wouldn't be the things that they are. So now let's compare those 3 accounts to this argument. If you think that that everything is going to be explicable in terms of this distribution of properties over space-time, you might have this puzzle, like, why that distribution as opposed to some other? Since there's no necessary connections, Hume would say, between the different parts of space-time that explain why you have some properties here and other properties there, there's then, one might think, maybe a puzzle about why things spontaneously come into existence. Though people who take up that account of laws of nature would disagree. They would say that someone's begging the question if they were to launch that kind of objection. But maybe the objection can be launched there. But suppose you take one of the other accounts. Suppose you say, for instance, that you're an essentialist. So Andrew Loke sometimes wonders why in any given region of space, like this room that I'm in right now, the electric field doesn't spontaneously increase in value for no reason whatsoever if the causal principle were false. Well, if the essentialist account were correct, then the reason why the electric field satisfies Maxwell's equations is in virtue of what the electric field necessarily is. So it's a necessary fact about the electric field that it doesn't just increase in a way that's inconsistent with Maxwell's equations. Or suppose that you like the DTA account. Well, in that case, there's various properties that go into the formulation of Maxwell's equations. Those are the equations that describe electromagnetic fields. And the DTA account would say that there's these brute necessity relations between those properties. Well, because there are those brute necessity relations between those properties, the electric field also won't just spontaneously increase in value. It has to satisfy Maxwell's equations because you have those brute necessity relations between those properties. Now, just because I know someone in the comments might bring this up, we have since moved past Maxwell's equations. We have quantum electrodynamics. There may be a description of electromagnetism past that. Doesn't matter. Whatever the description is of the laws that describe electromagnetism, whatever those laws happen to be, if you endorse either the DTA account or the essentialist account, then you're going to have a non-causal explanation for why the electric field doesn't just spontaneously increase in a room.
So to summarize, can we say something like, we can lose causality as a sort of fundamental property of the world, and it doesn't mean tigers are going to spontaneously pop into our room?
That's right. Yeah. So philosophers have readily example all these other ways of explaining why that doesn't happen. And, those accounts are going to work. They might work in terms of these laws of nature, but they're always going to fall into one of two different categories. They're either going to say that there's something that prevents things from beginning to exist, or they're going to say that in order for something to begin to exist requires a sufficient explanation, but not necessarily a causal explanation.
Right. Alex, we're almost coming to an hour here, so I want to try and wrap things up. Any more thoughts before we try and sort of wrap up?
Well, I wonder if we should summarize the dilemma and just really quickly explain why it's a problem for the Kalam on each horn without going into the details. Just like,
Yeah.
Yeah.
Do you want to do that, Alex?
I could have a go, but I think Dan should do that because he's a published expert on this area.
Before we do it, so to wrap up, just sum up the dilemma. I just want to ask you, Dan, you published this a while back. Have the advocates of the Kalam replied to your paper in the literature?
There's been very few replies. There was a blog post. There's a blog called Quantum Thomist or something like this. So it's not a published.
I'm sorry, I don't mean to laugh, but that does just sound like a funny name, the Quantum Thomist.
Yeah,
anyway,
I agree. It does sound like a funny name. So that blog is run by a physicist that is also a Thomist, and they part of what they get confused about in their blog post is they for whatever reason think that if you endorse the Metaculus, then you also have to endorse this kind of David Lewis account of laws. And that's just not correct. You can take up the DTA account or the essentialist account and conjoin that to the Metaculus. It's a sociological fact that people tend not to do that, but that's a perfectly valid move as far as I can see. The other place that the other person that's written some replies. So Andrew Loke has a book where he replies, and he also has an article where he offers a very brief reply, and then there was the debate that I had with him. And I mean, we already talked about why I find one of his responses anyway dissatisfactory, that he doesn't really take seriously the idea that there could be non-causal explanations that would explain why things are prevented from coming into existence, even if the causal principle were false.
Right. So tell me if you think this summing up is right? So we've got this hourglass universe. It's common in a lot of cosmological models, so that gives us a justification, at least for taking it seriously. We can't say it's right, but it should be taken seriously. If the middle point is not the beginning, then the universe can be past eternal, sort of threatening the second premise of the Kalam, that the universe began to exist. If it is the beginning, it implies time is not fundamental, and that threatens the causality principle, therefore threatening the first premise of the Kalam. So either way, we've got a problem. Is that a fair description, Dan?
Yeah, I mean, I would say, so a little bit more rigorously, I would say either time is reducible or not. If it is reducible, then the causal principle is probably false. If it's not reducible, then Craig and Sinclair's interpretation of these hourglass cosmologies is unmotivated.
Right. Well, we're at an hour, so I want to try and close it now for the first time, maybe. So thanks, Dan and Alex. Guys, if you've got any comments, please put them in the any thoughts, I say, put them in the comments. Please like and subscribe. And if you've got suggestions for future shows, also put that in the comments, and we'll try and reply. So we'll see you next time on the Sci-Fi Show.